Hello, fourth graders. Last week we learned a little bit about what makes up matter, which is atoms. This week we're going to be learning about properties of matter, also different states of matter, and ways to measure matter. So we're going to start with properties of matter to begin. For these lessons this week, you will need your science notebook and a pencil, because I will be asking you to pause the video along the way to take some notes in your science notebook. All right, so one thing you should know about matter is that just about everything around us is matter. So see this little notebook and pencil? That's a clue to you that that's something you should write down. So I want in your notebook for you to write down the definition of matter. Matter is anything that takes up space. So pause and write. Matter is everything around you. Atoms and compounds are all made of very small parts of matter. Those atoms go on to build the things you see and touch every day. Matter is defined as anything that has mass and takes up space. It has volume. That's what it means by it takes up space. So if you want to, you could also write that in your notebook. So remember, you can pause at any time to write what you want to in your notebook. I would recommend saying that is anything that has mass and takes up space. But I might not tell you along the way which ones to pause for. So feel free at any time to pause and write down things that you feel are important. So how do we describe matter? Well, one way we describe matter is with its physical properties. A physical property, and here's that notebook again, is anything you can observe about an object by using one or more of your senses. So go ahead and pause here to copy that down. So for example, if we're talking about using our senses, if we were looking at this classroom here, we might write down what we see on the computers. We might write down a sound that leaky faucet makes. We might write down how the desk feels. It feels hard. It might feel smooth. So physical properties are things like color, size, shape, and texture. Texture is just how it feels. So what I want you to do right now, since we're not in our classroom, but you're in your own little classroom at home, I want you to look around your room, whatever room you're in right now. And I want you to list a couple objects that you see. So a lot of us have seen a stapler before in school and maybe at home as well. So what I did was I listed a stapler as my object. Its color is black. Its texture is smooth. So if I feel it, if I touch it, if I run my fingers along it, it is smooth. The shape or size, it's almost rectangular, I might say, and it's small. I could write down anything else that I feel is important about its physical properties. So I want you to pause here, take a moment to write down a couple things in your room that you're in right now, and write down what color, what texture, what shape and or size, and then anything other about it. All right, so another physical property of matter is mass. Mass is a quantity of matter. One thing we have to be careful of is when we talk about mass, is that mass and weight are similar, but they are not the same. So your weight really is the force of gravity pulling you down on Earth. So newtons is a way of measuring weight and mass, or actually weight. So my weight on Earth is around 516 newtons, let's say, but my weight on the moon is around 90 newtons. Remember, it has to do with that gravitational pull. So weight is different than mass. Mass is how much matter is inside of you, how much you are made up of matter. So my mass would always be 56 kilograms. These are all metric measurements of mass and weight. But mass never changes. Your weight would change depending if you were on the moon or on Earth. There are two other important physical properties. One of them is volume. Now, volume is the amount of space matter takes up. Think of volume with liquids, and you can use a measuring cup to measure volume. But if you have an irregular shaped object, let's say a rock, and if you were to put that rock inside this measuring cup that had water in it, that would make that water rise. And really, there's not more water. It's just that that rock is taking up space in that cup. And so you are able to measure the volume of that rock that is irregularly shaped using water as your avenue in order to measure the volume of that rock. Another one is density. Density is the mass of matter compared to its volume. So let me put this in another way. Let's think of if I had a brick made out of cement versus the same shaped, the same sized brick made of styrofoam. Now you think of the mass of that brick with cement as being a lot more or a lot heavier, made up of a lot more stuff than that same sized brick of styrofoam, because that rock would be more, or the cement would be more dense than the styrofoam. So think of it that way. Density is the mass of matter compared to its volume. And we'll see these in some of these videos that I will attach to this assignment in our Google Classroom. These Discovery Ed ones aren't working for me. So I'll put in some videos for you to watch, which will help explain volume, mass, and density a little bit better. But remember to write down these definitions. All right, so next up, we're going to talk about the 3 states of matter. And yes, there really are 4 now. Scientists have discovered that plasma could be considered the 4th state of matter. But for our lesson's sake, we are going to be talking about the 3 more common states of matter. And so matter can be found in 3 states. And we're not talking about like Wisconsin, Minnesota, and Colorado. We're talking in a way of being, a state of being. And so the 3 states are solid, liquid, and gas. Every day you see and touch 3 states of matter, solid, liquid, and gas. But why is an apple solid while milk is liquid? What makes the air you breathe a gas? The answer is particles. Remember, all matter is made of particles, like atoms. The way those particles are arranged determines whether the matter is a solid, a liquid, or a gas. So what is a solid? A solid has a definite shape. A solid has a definite mass. And a solid has a definite volume. So let's use that bowling ball over here as an example. It has a definite shape. If I tap it, if I touch it, it's not going to change shape. It has a definite mass. That's not going to change unless I do a physical change to it, which we're not going to. And it has a definite volume. It takes up a definite amount of space. Now, solids, such as gems and bowling balls, are solids. They're particles. Remember, that's like their atoms that make them up, are packed together in tight patterns that give the objects their shapes. We'll see a visual of that in just a little bit here. Okay, so let's talk about liquids. What makes a liquid a liquid? Well, a liquid does not have a definite shape. So I like to think of that honey bear example here. You've probably seen these in the grocery store before. That honey really isn't shaped like a bear if I were to pour it somewhere else. So liquid is fluid. It can change shape. It takes the shape of its container. So this, let's say Kool-Aid over here, isn't really in a cylinder shape all the time, only if I put it in a cylinder. So a liquid does not have a definite shape. It takes the shape of their container. But it does have a definite mass. So no matter if I pour this Kool-Aid into this cylinder or a honey bear container, it's still going to have the same amount of mass. And it will also still have the same volume. So no matter what container I pour it into, that will not change its volume. So I'm going to say this again. A liquid does not have a definite shape, but it does have a definite mass, and it does have a definite volume. The only thing that will change in the liquid is its shape. And our last phase of matter is gas. Now, what is a gas? Gases are pretty fluid. They can change quite a bit. It doesn't have a definite shape. It will take whatever shape of cylinder that it's in, or box that it's in, or a room. Think about the room you're sitting in right now. It is filled with a gas that allows you to breathe. It's filled with oxygen. And so that gas isn't only limited to, like, let's say halfway up your room. It's not like you have to duck down and walk around your room so that you can breathe and the gas only fills it halfway. It actually expands to take up the entire space. So it does not have a definite shape, and it doesn't have a definite volume. As I just said, it expands to take up that whole space, which is really cool. So gases take the shape of their containers, and they have no definite volume. And if you think about the particles that make up gases, then they are spread so far apart, unlike the solids where the particles are packed tightly together. And then you can probably imagine that the liquids particles are somewhere in between, where they are allowed to flow a little bit more, but they can't change their volume. So here we go. Here's what that looks like. If I were to match these objects, so here I have a brick of gold, here I have a tank of oxygen, and then here we have lava, molten lava, which is a liquid because it's heated. And so looking at these particles, knowing what I had told you in the previous slides of which ones the particles are packed tightly, well, this looks the tightest to me. So I would match that brick of gold here. That's what the particles would look like if I had a very powerful microscope to look at that. Now, if I'm looking at these two now, this one, they're a little further apart. This one, they're really far apart. So I would call that one the gas, because they can expand to float around to fill up the entire space, those molecules. And then lava, the liquid, would be somewhere in between, where they can kind of collide and move around. So let's review. A solid has a volume and shape that both stay the same. That's what that would look like with its molecules packed together tightly. A liquid has a volume that stays the same, but has a shape that can change. So their particles are a little bit looser. They're more fluid. They can move around and take the shape of their container. And then a gas has no definite shape and no definite volume. It expands to take up whatever container it's in. So right now, these are all expanded to fill up that bottle, but if I were to uncork that bottle, they would escape and expand out even further. So the three states of matter. Our job here is we're going to look at this and see if we can figure out which ones are solids, which ones are liquids, and which ones are gases. Take a second here, pause the video, and see if you can figure out which one would be which. So you could write in your notebook a column of solids, a column of liquids, and a column of gases. And we have a chair, hot air balloons, water, clouds, orange juice, a hammer, and this is a rock or a boulder. Now with the hot air balloons, I want you to think about what's inside of the balloon. All right, pause the video to write that down. All right, so I am hoping that you put the chair in the solid, the balloon in the gases, the orange juice in the liquids, clouds in the gases, the water in the liquid, the hammer in the solids, and the boulder should go in the solid as well. So this week in your science assignment for the week, along with this video and other videos, you might see this attached as well, where you read an article about why does matter matter, and it's just a little bit more reading for you to do independently about solids, liquids, and gases. And then afterward, there will be either a Google slide or a Jamboard that goes along with it that I would like for you to see if you can answer after reading the article. All right, scientists, nice job this week.